Because my screen is shared.
So, yes, recording has started. Welcome, Akarsh. Let's get started. Over to you.
All right. Hi, everyone. I'm going to get into my introduction a few slides later. But what I'm going to talk about is tackling concerns around enterprise LLM adoption. And the intent is to have an engaging conversation. There's about 10 to 12 slides that I have. This should be enough content for about 45 minutes to an hour, assuming there are questions. If not, we might finish early. Feel free to stop me at any point in time and ask question, unless that's not the flow we usually do. So I'll get diving in. All right. So what you see on the screen is a very standard implementation of RAG architecture. And for those of you who are, probably not yet started their journey, this is a very initial version, like 0.0001. So what you have, if you take my cursor from the, sorry, I'm getting a issue with the pen. All right, sorry. So what you have starting from left hand side to right hand side is a simple flow where we are building a RAG. So in general, you start with a user query. That's point number one in blue color. And then you go and hit an orchestrator, which is essentially taking a bunch of important parameters. And there are a bit of functions talking to each other, and they are coordinating amongst themselves to kind of get things done. Now, what's happening inside? Is this a serverless architecture? Is this a microservice architecture? What sort of architecture is this? That's still to be discussed, but usually there's an orchestrator. This orchestrator in some instances, if you look above it, which is the box mentioned around dot point number 2, could be connected to something like a prompt store or a key value store. Now that key value store could be supporting in form of a cache or prompt store. But again, for basic implementations, I have not seen even a prompt store or cache. Moving further, you would branch out into doing a couple of things. There would be a line number 3 going out, which is pre-processing pipeline. And essentially pre-processing is breaking your data, joining the data, sticking around a bunch of things, standard stuff that we are used to doing. Couple of additional things could come into picture from a LLM perspective. Let's say, you're dealing more with unstructured data, for instance, than you are used to. So that's the pre-processing step. And then below it, you have a kind of an embedding model, which could be an OpenAI embedding or a Mistral embedding or a Llama embedding or a BERT embedding, whatever. And you're connected to some sort of an external LLM provider, which is by far and large a transformer store, Hugging Face, things like that, or an OpenAI implementation, which is the point number 5. All right. And then afterwards, you have a orchestrator connected to a bunch of more flows. Can these arrows be more better connected? Absolutely, yes, they can be, but this is more of a basic implementation. Coming back to the orchestrator, it could be connected to a knowledge base, which is a must to have for enterprise RAG. A knowledge base is essentially your vault of enterprise information, which is basically your documents, your guides, your SharePoint data, or literally any data that you want to build RAG on top of it. RAG essentially is retrieval augmented generation. So what you're doing by bringing in that data is powering your searches and making it much more smarter. There are two additional components like the Groot you see, which is more of a cartoon. It gives feedback loops. Now it's supposed to exist, but in most cases it doesn't exist or is largely human driven. And finally, at the very bottom right of the slide, you have storage services, which is physical storage like everywhere else in the system. So you could have a traditional document database. Graph databases are becoming popular. Vector databases are becoming popular again. Whether you have it or not is not important at this stage. So this is basically some form of your RAG architecture, and the next series of 8-10 slides is focused around talking this kind of workflow and understanding the operational challenges that you need to think about implementing these in production. The usual form of interaction of LLM is this by far 3 ways. One is you just go into OpenAI or whatever, Gemma or Mistral or Claude, and you just chat with it. That's pattern 1. Pattern 2 is what you see on the screen, RAG, which is very popular right now. And then there's a pattern 3, which is getting into an agent kind of workflow, which is evolving. It's not it yet. It's yet to see the light of day in most enterprises. So that's also evolving. And then you have a further down the line another path of fine tuning. But in most places, RAG is what is selling, RAG is what is working, and RAG is what is giving value. And we'll also talk about value as we go. All right. Moving forward, a little bit of introduction. That's my daughter. That's not me. She looks like me, but I still think myself as an architect, though, and an engineer. I haven't done a lot of that for a while. But a quick introduction about myself. I'm venturing into 13th year of my IT experience. Have been building systems mostly throughout data analytics workspace. So I have dealt with mainframes, Teradata, big data, a lot of cloud providers, Azure, AWS, and for the past 6 7 years, basically building AI systems, and for the past about 2 2.5 years, building Gen AI systems. So a little before the Chat GPT came into market, GPT 3 and GPT 2 was around, but we have done some experiments around it. But again, that's my background. If anybody wants to connect with me, there's a link bento.me/Akarsh. You can just find me there, and the rest are my YouTube handles. Moving forward, now the diagram that I showed before, let's go back and see. If you take a second, there are some concerns here, and these concerns originally start from the perspective of building a system rather than doing an experiment. Those two are very distinct operations. So can you do a RAG architecture in Jupyter notebook? Absolutely yes, which is what the same workflow will run. But if you think about it and look again, see all of the additional red marks that are around every top of the block. There's literally a concern at each step. To give you an example, in the first step itself, we have we are used to just calling the orchestrator, but traditionally if you are building an API based systems, there's a thought of an API gateway which doesn't exist in most enterprises when implementing a RAG architecture or a AI system or building a platform. If they have more transactional systems, they would have that API gateway, but that's missing in it, and that's just an example. So moving forward, these are some of the things that you could focus on and what we will talk about. So you will need to worry about API gateways. We'll need to talk about security, and security is not just limited to RBAC, but it extends to actually data and models. And with Gen AI, it becomes much more prominent because you're essentially consuming a model built by somebody else. You don't know the data that they have used to build that model. And if you are into a service business, and let's say you're using something like Copilot, GitHub Copilot, which is a great coding assistant, it has been trained on all public data from GitHub. Now, are your consumers okay in having a piece of code written by an AI bot? And that is an open question. It falls under borderline compliance because somebody can come and claim that this piece of code is mine, and they can make a copyright claim, and that's a very long and deep rooted conversation. But essentially the notion of security has extended with Gen AI. The importance of caches are becoming high because previously, if you see, chatbots were very very limited to consumer facing application. You'll have a customer kind of chatbot, but now the notion of chatbot is changing, right? You're no longer doing servicing of customers or consumers. What you're essentially ending up doing is building a chat interface for literally every kind of problem. So there has to be more deeper conversation around caches, specifically when you build a end-to-end system. Feedback loops are also important. Usually in transactional systems, you will have something like logging and monitoring, part of observability stack, but feedback loop here is essential for you to improve your system in general. Your quality of RAG has to improve, which is to say that the kind of answers you provide back on a question has to improve over a period of time. So even something simple like Chat GPT will give you a thumbs up, thumbs down, and you might need to go much more deeper, and we'll talk about some of those problems. Then is the business value realization, right? With traditional AI, the business value realization was very well defined, or at least as well defined as it can be. For instance, you could be doing something like a prediction problem or a forecasting problem, and you have a way to measure it, right? You can say that this is how close my AI told me, and here's a delta on the revenue. With Gen AI largely, which is venturing into the improving productivity space and some sort of consumer facing applications, measurement of business value is still an ongoing conversation. So that has to be thought around. Scalability, obviously, every system design problem throws in a scale challenge. Now, what's added is we were processing unstructured data before, but GPT have literally changed that. I mean, the amount of unstructured data that's getting processed and talked about, it's humongous. So much so that you are now looking at a completely new database category, which is the vector store, right? So the scale at which it operates and the representation of unstructured data and dealing with unstructured data is becomes a larger concern that it used to be. Then comes integration, right? If you want to have a Gen AI platform, you are given a problem of putting all your enterprise knowledge in one place, which is often not the case. We talk about data lakes, data warehouses, and whatnot, and but most of the data is actually scattered around. You have PDFs, guides, documents sitting in SharePoint. So that is a challenge. Moving forward, enterprise providers and working with them, now you're not building your models, you're working with external providers, so you have to understand their regulatory, their compliance, their technology, their scale, and all of that. Like a lot of you might have seen that when you hit OpenAI, you are given with timeout errors or the number of calls have exhausted for a certain given day. How do you deal with that for a critical application? Then comes ethical conversations and the governance around it, right? Who gets to approve a Gen AI project, right? There's different facets like the ones we talked about. User experience. Oh, traditionally, when you had a UI, there's a lot of UI themes coming out. There's a lot of experiences that you can build using low code, no code, or regular code, and people can do a lot of BI, change the kind of slides they have, change the kind of interfaces they have, tailor it, dynamic UI, mobile apps, and all that. When you just have a chat, what do you do with it, right? How do you improve the experience? That's an evolving question. And lastly is expectation management. I mean, how many of us have bosses who just heard about Gen AI and then said that we also want it, right? So that's essentially the plethora of problems that we have talked about, and some of these at least we have solved to some extent basis my past experience, and we'll talk about that more deeply. So let's see what we can do about them. And the next set of slides that you will see are completely focused around solving them and solution. I'll take a pause and just check if there are any questions. Vivek, any questions in chat? I cannot see the chat.
No, not yet.
Awesome, cool. Let's move forward. So basically, now the first content, the thought is that the LLM itself needs to be monitored. And there's different areas, avenues, thoughts that we need to put in when we think about the LLM itself, because it's a model that we have built or we are consuming of somebody else. Previously, when we were building models in traditional AI, we had our own data. We would build the model and we would be able to define the measures, right? Let's say it's a classification problem, you can put up some sort of a confusion metric. You can probably still do most of that. However, the data is not in your control. So, how do you measure and what do you measure? You can't measure accuracy because accuracy for a chat problem is very, very subjective. The same model is literally giving you answers to future forecasting problem. If you give it time series data, the same model is telling you classification. So how do you get into monitoring it much more deeply becomes a problem to be solved if you think of it from an enterprise perspective. It is, I mean, it's a problem literally everywhere, not just in an enterprise lens, but for enterprises where you have different departments. Let's say you have your sales, you have your marketing, you have your finance, you have your consumer facing applications, your supply chain teams, your procurement teams, all of them using the same set of apps or the platform that you're building. How do you differentiate and understand and monitor needs to be looked at. So here are some thoughts to it. Again, I don't intend to be an expert in any of these, but most of these are implementations that my team has built around. So kudos to them. Now, the first part could be, the response versus ground truth. Let's say you are doing a RAG architecture. There are a certain set of documents. The simplest of examples could be, you have a HR chatbot where you have a policies. So your policies are very well defined. The Wordings in policies are very well defined, and the boundaries within them are very well defined, compared to a general LLM response, which tends to sway around a lot. I mean, you can force it and you can control it by prompts, and you can, when you build a RAG, that's the whole goal. But the measurement criteria becomes response versus ground truth. So whatever is the user getting and what we are seeing in the data, which is the ground truth, that needs to be validated and measured. So this is not the data on which the model was trained upon, it's actually the data on which RAG was built upon. So you're essentially evaluating the RAG. So the response versus ground truth, and it can come in various forms. You can have the traditional scores, bird score, blue score, rogue scores. There's a, I don't know, there's a lot of tug of war going around what scores are useful for evaluations of LLMs. You can get into that academic exercise and find a bunch of them. There's Helm and there's research papers published all around, but you have to start somewhere. So we started with what was well defined and available, and then as you see the list, it goes on progressively. Then you have your divergences. You have your KL divergences, your distance matrices, Hellinger matrices, Kolmogorov matrices, and all of these essentially intend to help you understand the ground truth and the distance from the response. Then there is an additional technique which is called LLM based scoring. So you are using an LLM itself to give and validate the response of an LLM. So one approach that this works is you have think of it as two different personas. One is a developer, another is tester. So a lot of people, what they do is they use a smaller model for serving, which is they'll, let's say, use 3.5 for giving response, but they'll use 4 for evaluation. So testing is actually costlier. So you could rely on those kind of strategies. Again, that's not a recommendation, it's most of something that works around. So you build your pipelines using, let's say, GPT 3.5, but you graduate and mature your testing pipelines to 3.24. The idea being that larger models can deal with more complexity. Similarly, if you go into something like Claude ecosystem, you'll use the Haiku and Sonnet model to do your serving and suggestions. But if you are getting into evaluation, then you get more bigger models like Opus or the 3.5, etc. Now, evaluation in itself is a very costly exercise, so you might not be doing it always. At the same time, you might be validating against different responses from different LLMs. Let's say your pipeline is designed in a way that it hits multiple LLMs just from an experimentation perspective. So you could be scoring all of that, and maybe after the initial 3-month period has passed, you could be seeing what LLM generally gives you a better score or across these numbers, and you could select that. So that's response versus ground truth. The second is prompt versus response as well, right? Now, when you deal with prompt versus response, you have to measure relevance, prompt entailment, how far it is from the prompt, the information density, sentiment, specificity. And these are contrasting measures compared to prompt. So previously response was compared to ground truth. Now response is compared to prompt itself. So you will need to build in these uh, evals within your pipelines or within your whole evaluation framework. This whole kind of goes towards an evaluation framework idea. The third itself is prompt, right? And prompt is the most important piece of information in these conversations, because kind of helps you drive the cost, kind of helps you derive the tokens, etc. So there's a bunch of different kind of things that you need to do or build observability around prompts. For examples, words, characters, tokens, frequencies, sentiments, all of that, which are general things, right? You can calculate that. Then there are more trickier areas like adversarial testing, fairness testing, jailbreaking, injections on the prompt. So let's say you have an HR chatbot again. You don't want the HR chatbot somebody to inject a jailbreak and say and get an answer as to tell me I mean, what's the CEO's salary, right? And essentially the LLM, if it has access to the data, if the RAG has access to the data, it might give that. So the prompt validation and the quality of prompt and evaluating the prompt itself becomes a challenge. The next three pieces of information, or the next two, are more operational. Again, all of this is operational, but then you get on to health, the latency, the throughput, the error rates, the resource utilization, etc. Now, this is from a perspective of the LLM, not the overall system. So essentially, if you have a user and some sort of an API endpoint, this talks about the health of that. You obviously need to look at the health and the whole trajectory or observability across the system, but this essentially focuses on the LLM specific needs. And then you get into the cost, the compute, if you have a self-hosted model, data storage, data transfer cost, API users, observability cost, and we'll double click on some of these points in much more. Now, cost tracking and the observability is slightly different in LLMs, because traditionally, if you hook up something like a Datadog, the amount of cost or money you end up spending with Datadog will increase. Why? Because it generates a significantly large amount of data, right? Think about it. If your every call, every chatbot is, or every communication is getting observed, then the amount of data generated is significantly high. This is even higher than traditional server logs, which are, historically the most biggest chunk of data. So if you want to get into observability, it's not a simple question of, measuring a bunch of these. It's actually a question of building a platform and a system large enough to sustain this, and understanding the needs around evaluation as to what do you need now, what do you need in the future. You'll need to dedicate a bunch of engineers around it. You'll need to put in architects around it to be able to say that, all right, this is how I'm going to store my logs, and then this is how I'm going to store and process them. Oh, sorry, this is how I'm going to store, and this is how I'm going to process them. Post processing, I want to extract these numbers, or again, some of these are on the screen, and then I'll remove the data, or I'll archive the data. Because if you keep on an active log, usually in logging and monitoring, you get into deep dive only when there's a failure or error happening, right? Here, it's not just about errors, it's actually about consistently evaluating it, what's giving better responses. And given the rate at which the number of models are coming out, that also is something to think about. All right. So, yeah. And finally, the last point is feedback loop tracking, which gets into human in the loop, the reinforcement learning part. We have not implemented that because it gets much more deeper, trickier to implement, to truly improve the model. At best, in initial days, you could do a thumbs up, thumbs down, capture feedback, written feedback, and adjust some of these responses. But this will be becoming more prominent if you are doing fine tuning, which we have not done. So, yeah, that I don't have a lot of deep insights into it. Okay, I'll take a pause again, grab water. Are there any questions?
What is information density?
So, information density, when you have, let's say a document or a policy, right? And policy has, let's say it's a leave policy. So leave policy will have different kinds of leaves, the reasons and the laws around it, like this is what you can take, this is what you cannot take, this is how much will be paid when you leave the company, and all of that. And then it'll have a bunch of other supplementary information like the change log for the policy and all of that. The information density essentially within the response refers to how much of factfulness you have in the response back to the user, and how much of it is generic information. So if you're doing RAG and you have a 4-pager leave policy compared to a 12-pager leave policy, how have you extracted the information and how densely you are packaging it and passing it back to the user is the measurement of information density. Now, how can it be measured? Using some of these numbers, but there are more ways to measure it. Like you can get into more deeper into topic modeling, and you can understand what your data actually has, do a lot of different similarity score calculation, and can help you with the information density.
Yes, some more questions on chat. You can
Okay,
stop share and see the chat.
sure, I'll do that. Feel free to unmute yourself, I think. Oh, nice and creative profile. Thank you. What is, assuming we built an LLM using 3.5 and 4, I'm guessing. So, Vikram, the question is more. I see Vikram has left the chat, but not sure if Vikram is around. So, I'll still try and answer the question. So, assuming you have built using 3.5 and you have 4.
I'm still here, yeah.
Okay, sorry. How do we know the testing is accurate? This is a loop. There's no end to it. Uh, An extension to the question is, how do you know if the LLM, the 4 model, is giving a good response or not? And we spent quite 2 3 weeks around it. The fact is, if you are implementing, you have to start somewhere, and you have to trust it that it's giving some responses. A good part of the testing process will be human at first, but if you have been able to tailor down your prompts right for testing and provide it with examples which are again human validated in the first place, so think of like, multi-shot prompting and COT examples for testing, not for the responses, then you are good. Why the model variation helps is because it's generally assumed that 3.4 is better than 3.5. You can use both, like for serving 4 and testing 4, it doesn't really matter, but that's a general understanding in case. And specifically, if you want to control the cost, you would end up with smaller models, right? You might want to use Haiku for smaller kind of query. Let's say it's a customer facing chat application, right? If it's a B2C chat application, you'll go the smallest model possible, or it's a code recommendation system where you need fast responses. So you'll need a smaller model there, but evaluation is not going to be happening all the time. So then you get onto bigger model. Could you tell the connection between feedback loop and LLM build for testing? So feedback loop is very interesting. Let's say that you have RAG and you have some vector representations of it. I'll try and double click maybe in few sentences. So you have a RAG which is not significantly huge, couple of GBs, and then you have a good vector representation of it. The vectors are pretty dense, the topic modeling is perfect and all that. Let's say you have done all of that, and when you get a response, right? Let's say, for example, you are serving a certain geography, right? And in that geography, the relevance of the answers compared to different geographies are, you're getting differences, because what's relevant to an Indian user might not be relevant to a US user. So you can capture some of those feedbacks, collect that back, and give it into your RAG pipeline as an additional vector to feed it back into the topic modeling. So that process works as a feedback loop. This is not a great answer if you just look at the whole reinforcement learning concept where this should be headed, but it's generally okay. If you want to go further, then go into fine tuning, and there you will need human in the loop reinforcement learning, where you, based on every feedback, you update a penalty model, and then penalty and reward model, and then you apply that back to data back to the fine tuning process. Hope that
Got it.
answers it.
Yeah.
Yeah.
Thanks, Akash.
Roop is asking, how do you handle scenarios if model performance decreases significantly? It's not realistic. Uh, it so Roop, two questions back. If you have actually measured, if you have built your evaluation pipelines, which by the sound of it you have not, you should have already seen the performance getting degraded. So this is the testing part. If you don't have a testing pipeline and evaluation pipeline, and you are seeing the model performance decrease, and you're further adding that you cannot remove the model from production, I would give you a couple of thoughts. A, you have built your system in a very tightly coupled way where the model cannot be changed. That's not a great way to approach this. You should have a very flexible system where removing the model or decoupling the model only impacts the prompts, because prompts are not interoperable. So you should have different prompts for each model, and you should be able to remove it from production. Having said that, since you have not been able to, you can look at concepts like AI gateways, and there are a bunch of young startups popping in the space, and they can help you tailor and solve some of this. Another way to look at this problem could be, you go back to your prompts and see what's causing this difference. Like, can you improve your prompts? So essentially two things: A, it boils down to improving the prompts; B, it boils down to improving your or changing the model. If you cannot do any of them, then what can work is that look at the RAG and look at the source of the data. Is your data very wide? Is your data not specific? And maybe try and breaking that RAG into smaller, RAG for something, RAG for something else, and RAG for something else. And then combine those answers and give it. Any of these techniques or all of them combined could work. I hope that answers it. Sorry. All right. I'll share again. Sorry about the sharing and all that. Is my slide visible? Can somebody confirm?
No.
Not visible.
Damn it. Okay, should be now. All right. Moving forward to cost management. So the first part was about LLM. The second is really about the true cost of Gen AI. We'll get into performance after this. So here I'm talking very specifics into the cost. So, and this by far and large is from an infrastructure perspective, and a little bit from a, you know, maybe model and data science perspective. So one challenge which most of us have is if you're hitting OpenAI endpoint, you have some sort of an enterprise license to it, or you have some kind of a personal deployment or a custom enterprise deployment of OpenAI, either from Azure or something like an Amazon Bedrock. This becomes a shared service, which is to say that if you have 20 different applications or 20 different departments, each having 4 projects where Gen AI is used, this is a very likely scenario because everybody is wanting chatbots these days, everybody is wanting some bit of Gen AI. So if you have, let's say even for a mid-sized company, 5, 6 departments, each having 2, 3 chatbots, what you have is 10, 12, 15 projects where each of them are having some kind of shared infrastructure and a large kind of personalized or dedicated infrastructure. Dedicated infrastructure could be databases, it could be your web apps, it could be your anything and everything else, Kubernetes cluster, anything that you have in cloud, right? And then the OpenAI model is shared. Why is it shared? Because it's actually becoming a problem with most of these providers to get dedicated instances. There's a long list. So it's not that it's technically not possible. Microsoft, at least with Microsoft, getting a dedicated instance becomes a challenge because a lot of networking requirements come into play and all of that. So for by far and large conversation, it becomes a shared service, the LLM piece. But then if you start to get more deeper, you have challenges like the RAG has to be department specific, but the LLM is shared. So how do you attribute the cost? So that's one problem. The second problem is how do you end up scaling this, right? There's a very somebody has a large traffic and you don't have a dynamic scaling built into it. Your LLMs are just going to give you a timeout and you'll not be able to attribute cost and all that. So that's essentially the problem that we are trying to talk about. Not all of these have very well defined solutions. However, given a decent amount of research that we have spent, I think it would be good to just start somewhere, like focus on the 80% and 20% keep on researching. Otherwise, there's no good answer to this. There's a bunch of services that you can control, but there are some services like indexes and searches which becomes very, very difficult to attribute cost around. So that's what this slide is about. So you implement dynamic scaling with cost attribution, a bunch of mouthful, but essentially the idea is that you can use methods like, if you read the second line, you can use something like resource tagging and custom matrix. You can count your tokens, and based on the number of tokens you have and based on who logged in, find a way to define which department they belongs to, and then do a total at the end of the month. So that's a very messy way of looking at cost. That's one way that works. And the allocation system needs to be important. Either you get into a budgeting exercise which tells you which applications will consume high, so you ask them the non-functionals for each team that how many number of hits you are anticipating, and then proportionately distribute the cost if you cannot actually measure it. But if you have been able to measure it, that becomes a good way to do it. And the ways of measuring, as I just said, you can do resource taggings, you can do custom matrices, you can count the number of tokens per response, and that's a very deep exercise in itself because there's too many different kinds of tokens: input tokens, output tokens, first hit tokens. uh, there's a bunch, and then depending on the model type, the calculations of the tokens also changes and the price changes. So there's a bunch of parameters to look at there if you want to get into calculating it. If not, budgeting exercise can work, but it's important to do this. Otherwise, what will happen is that few months later everybody starts scaling up, and then your OpenAI cost or your LLM cost starts to shoot up, and you have no way to explain to your the CFO or whomsoever you report to, your boss, that how do we manage this. So that's the first 2 points. And then moving forward, the RAG architecture cost optimization, two specific things. If you are specifically into RAG, like you are doing indexing and you're doing vectors, you will have to understand the trade-offs between doing a initial one-time indexing and frequent indexing. Everybody literally, when it comes to implementation, right, just default to no problem, let's just reindex the data, we have some changes coming in. But if you actually look at the amount of data reindexed within that, let's say a 1 week period, and if it's a very slowly changing dimension, you will lose a lot of money. It's not worth the business value, and we'll talk about business value towards the end. So look at indexing versus reindexing specifically for things like where you have searches, where you have dynamic data sets. So try and do incremental indexing strategies. Try and build your data chunks in a way that they support incremental strategies, indexing strategies. So instead of essentially every time reindexing everything, you are indexing only a small chunk. Sounds like a very traditional advice. It is. You'll be surprised as to how many places this is not implemented. Then comes a newer kid on the block, vector store. Vector stores are tricky because there aren't a lot of good implementations or at least positive reference architectures around it. But what can work and what we have tried is you can implement techniques like dimensionality reduction, which is very traditional method. If you have sparse or if you have a low size corpus, if you have a corpus which is very very large size, then this becomes a problem. Essentially, you can do dimensionality reductions. Whatever techniques is completely data specific, and that will decrease the storage requirements, and it will significantly increase the retrieval quality. It will impact the retrieval quality. My bad, it will not increase it. Quantization is also a lossy way. It's essentially compression of the vectors. So what quantization is basically, you usually represent the data in 16-bit or 32-bit or 64-bit floats. You bring it down and you make it 4-bit or 8-bit. This causes a large uh, reduction in the quality of vector representations again. So both of these are lossy techniques. But again, there's a cost versus value trade-off. So if you are seeing high cost, or if you have data sets which are less frequently changing, and they are very you know wide in terms of knowledge base, you should implement these techniques, things like your policies, documents, guides, SOPs, and all of that. But if you have data that is very fast changing, then you will have to look for better techniques. Chunking of data, or actually doing a lot of pre-processing before feeding back into vectors could help around. Finally, serverless is a great way to reduce the cost, and it can help you do a lot of indexing during idle times. So you can rely on spot instances on on AWS, and similar kind of approaches, or for doing indexing, and these are really really cheap infrastructures. You can also look at completely server based architectures like Lambda or Function for doing on demand indexes job, essentially only paying for the compute time. Now usually the approach that people take is have some sort of a server or a database cluster and just run these, which is very detrimental to cost. So yeah, some of these practices have been seen, observed, failure, and evolved. So most of these are around what we have implemented and what we have experienced around. All right, I'll take a pause again and see if there are any questions. Okay, so there's only one question I see, which is, please elaborate incremental data indexing strategy. Okay, so incremental data indexing is essentially when you build indexes, right? It depends on the indexing platform you're using. Let's say you're using Azure Search or something on AWS. One way to do indexing would be you have all the data and you index it. And incremental indexing would be, let's say you have change data capture built on that. So you apply CDC techniques, which is change data capture, and then you only add those additional increments as indexes. So your previous index still stays the same, and only small chunk of data which is coming in from CDC or similar sources is getting indexed and incremented. This leads to some sort of a challenge, like in a longer run, like you have too many small indexes, and uh, the index becomes very wide, so the the quality of index can decrease as well. But you should essentially think of it as a reduction in cost now, and then again fixing index maybe 6 months later. So that's probably what I was trying to say about incremental indexing. Second could be more from a data lens, right? If you have data that can be broken down, that can be made smaller sizes, you can also first realize the value of it and then do indexing. So that's in a way incremental indexing, but honestly we have done the first one. uh, I hope that answers it. Quickly checking before moving forward. All right, no more questions. Moving forward. Cool. So getting on to performance, there's 3 4 different kind of performance areas to look at, and again all of this is RAG focused. Please do understand that if your application is having much more components, be it in the form of databases, app services, blah blah blah, then you'll have to focus on that cost. That cost is separate, and that performance is separate. Everything is separate for that. This is pure RAG. So when you have RAG, right, 3 parameters essentially matter. You could have much more parameters, but from a performance lens, 3 matters. Usually, I personally don't believe you should think of performance before implementing the system. So ideally, get to this conversation only if you have a system. If you are getting into performance conversation when you have like 5 PDF documents and 200 API calls, no need to worry about it. Just move forward from it. Use the benefit and then come back to thinking this. So RAG specific performance benchmarks, indexing speed, how fast can you index the documents, goes back to the previous point about cost. The faster you index and the more you index, the higher your cost and the slower your application becomes, which leads to point number 2, which is query latency, milliseconds per query. So the bigger your index is, the bigger your data set is, the slower your query could become. And then RAG accuracy itself, which is some sort of cumulative gain, or matrices like mean reciprocal rank. And again, I just know these names. I don't know the implementation of these. I know the performance side of it. So when you are fixing or patching performance of a RAG, look at your indexes. Highly likely that they are causing performance and this is computational performance. Please understand, we have already talked of a different area of performance, which is the response performance and all of that. From a functional perspective, quality of response, this is all computational performance. So indexing speed has to be looked. Query latency, if you can only look if you are having observability, this is very hard to actually implement. And retrieval accuracy goes back to our first slide. The second is the vector database itself. The database essentially, it's a vector databases are very very interesting conversations these days. Some products are just give me a second. I want to take water. So some products are coming in new, your Pinecone, VV8, and all of that. And then most of other traditional providers are bringing in vector as a traditional data store. Even Snowflake has it, or is most likely going to have it. So the idea behind vector stores. I'm getting an echo. Is there a question? Or if everybody can mute, yeah, much better. So the idea behind vector database optimization is that when you have a database which is essentially storing vectors, how do you optimize it for 2 things? I'm still getting my echo back. Uh,
Everything good here, nothing at my end.
okay, maybe I'll just continue. So you optimize for maybe two would not be a good call. Maybe more couple of more different dimensions. So one way to optimize is essentially cost and performance. The other way is how can you get faster similarity searches. Traditional problem, as your database size grows, your query is slower. So you will want to experiment with different indexing algorithms. So Pinecone has a bunch of different algorithms to talk about. Again, I don't have expertise in it, but if you most vector databases has a bunch of indexing algorithms. So they would help you balance between search and speed and accuracy. And an extension to this, which I've not written, is if you have a cache sitting in between, or if you, as a level 1, get the data first quickly from the vector store, and then do a little bit of some similarity calculations, you could also speeden that up. The second part is the choice of the algorithm itself, which is again dependent on a lot of different parameters. So you need to have a flexibility in terms of the algorithm you select. So essentially experiment and choose. So two pieces: A, the index pieces, which is impacting the computational performance; B, the similarity and the better answers is also part of it. There are additional techniques where people come in and do ranking, re-ranking after getting answers from vector databases, and I've heard that they are working great, but I have not personally tried them. uh, they are just too much of juggling with model architectures. Essentially, the key concept behind is that vector essentially are compressions. So you have some sort of an encoder architecture, but if you want to do re-ranking, you follow some kind of a decoder architecture, or maybe vice versa. I'm mixing them. But you can look at essentially responses from vector databases and then even further do re-ranking to improve your similarity searches and scores. And finally, caching strategies, like I was saying, you can literally cache everything. And caches are, these are different kind of caches, because traditionally caches are key value stores, very very deterministic. Here it's non-deterministic, because the responses can be similar to a previously asked question, or the response should be similar to a previously asked question. So you'll have to again play with experiment and choose between the similarity scores, so what works. And you have to define your cutoff and threshold, like maybe you want to stick at 95%, 97% or higher. How do you do cache invalidation and validation becomes too much more deep into engineering. We haven't ventured in it, but at some point in time we will have to, because as the size of your RAG grows, which is the size of your enterprise knowledge base grows, on top of which your RAG is built, a direct impact would be on the vector store itself, and then a further cascading impact would be on the size of the cache itself. So you'll have to think it through and define the performance around it. So yeah, observability is the key. Ending the slide with that. I'll hop on and see if there are questions in the chat.
I have a question.
Sure, please go on.
Uh, you're explaining this vector databases. I also tried to explore a few. Just wanted to have some insights from you also. Like, do we have any vector DB where we can have hierarchy of collection IDs, like collection ID within collection ID?
Okay, so see, the hierarchical world, you are actually talking of not a vector part, but you're talking of something similar to graph, if I understand it right. RAG with graph is becoming a very very prominent discussion, where you have some sort of a graph database where you are plugging in the notion of RAG, and the hierarchies work better in graphs, arguably better. Can these hierarchies not be compressed in form of vectors? They can be. Essentially, hierarchies would be some form of trees, and if you have the representation present in form of trees, you can vectorize it. I have not specifically worked with it, so if you're looking for directions, I would suggest parallelly look in graph and vectors at the same time, but look at them only if your data sets are of some size and value. If your data sets are I don't know, 100 MB, couple of maybe small, few hundred MBs, don't get into the concept of database at all. You can just have dense representations in form of vectors and graphs both at the same time, and experiment with them what works. And about a GB of data keeping in memory is not a very difficult activity, so you can literally keep them in memory so that you don't have performance problems. But if you have a larger data, then do look at graph databases and vector stores as well.
Okay, thank you.
Okay. Quick check if there are any last follow-ups. Suresh is asking, can you explain reciprocal rank? I have no clue about ranking and re-ranking. I've only studied it academically. I can make a guess, but don't want to. I think that should be very well documented technique. I'm sorry. All right. Going back to the slide. So yeah, moving to the last two slides. The last is more gearing towards business. So if there are any business leaders here, or well, for everyone, understanding the business value around Gen AI is becoming a challenge. Uh, a lot of it is tied back to infrastructure. These are the best times to be in the technology space, in the technology world, because all of these are tech driven conversations. So business leaders are also tech savvy these days. But having said that, let's look at some KPIs and matrices. So I've just put some thoughts which are generic in nature. Again, these KPIs are not from my organization, but these are just general ones that can be measured. So if you are getting into realization or rationalization exercises, you will need to do use case specific ROI analysis. And let's say you have customer service chatbots, what can be a good metric? Usually any reductions in time or reduction in cost are great. Or even if it's completely consumer facing, B2C, improvement in quality scores could be great. So your reduction in average handling time, your first contract resolution rates, the number of queries resolved within a day, the deflection rates. And deflection rates are things like, for smaller queries, it's not going to human beings, it's just giving them good answers. That actually influences the agents, which is human agent productivity, and well, essentially reduces the number of requirements, cost per interaction, and all of that. So for all kind of consumer facing applications, think in terms of a what's leading to saving human time, b what's leading to increasing consumer or customer satisfaction, and see what's leading to reduction in the overall time, like optimization of the process. How do you get into customer satisfaction scores? These are very tricky areas. Again, doesn't I'm not no expert in this, but people usually only give feedback when things don't go well. So that thought kind of contradicts this idea of CSAT scores. But again, uh, you essentially need to look at KPIs. For HR service portals, similarly, you'll have to do a reduction in ticket volume. You'll have to see first contact, time saved on routine inquiries, like simple policy queries and all of that. So you could do that. And most of Gen AI use cases so far are revolving around some sort of productivity lens and use case. So yeah, that's what is there. And finally, tying back to infrastructure and cost attribution becomes essential, because if your different departments are coming to you, how do you attribute and associate the cost back to the different teams? So you need to ensure that there's a project and user tracking available. Something like RBAC can help you, and maybe integrate to your single sign-on. And then finally, what I've already touched upon is look at your databases cost, look at your observability cost, and don't think that token tracking is the golden thing. It's actually, you'll very soon realize that the cost of LLMs is probably not the biggest cost. In fact, it's not even, at least in our use cases, top three or something like that. So there's much more cost to Gen AI than the actual hitting of API costs. And then observability is key. Most people are not building observability, but it needs to be a very, very strong concern if you have intentions of scaling Gen AI within your enterprise. And indexes, caches, usually, which are things of the past. People don't like to talk about these things anymore. Everybody assumes cloud auto scales, but yeah, indexes, caches, they need to come back and make a room. All right. So that's on the business value realization. I'll probably end the slides and then just move to conversation. So TLDR, which is too long, don't read. Enterprise LLM challenges are vast. By far, you have business value realizations on the extreme right, and you have cost management sitting at the extreme left. You need to worry about attribution, you need to worry about indexes, performance, integration complexities, difficulties in monitoring, infrastructure challenges. And then some of the areas which I've not touched are data privacy, auditability, user adoption. Becomes very difficult to push Gen AI specifically in areas where a lot of regulatory risk is high, things like finances, healthcare. So deeper areas, data privacy becomes a super super strong concern for most enterprises, because auditability, logging is important, legal aspects are popping in. So the laundry list goes on and on, but it's significantly important, going back to my title of the slide, that we keep focusing on the operational aspects. Take an 80/20 approach by keeping on 20% as your research, like, because the world is literally changing by the week, newer models are coming out, but can you actually implement a new model every week? People are going to throw you out. So focus on building 80% of it, and then things can be improved. Yeah, that's the end of my talk. Thank you for listening. I would just stop sharing and open for questions.
So thanks, Akarsh. It was a good session. Suresh here. When you said a database cost, right? What do you mean by database cost here?
Yeah, so okay, I think I touched upon that in the previous slides, but the database cost essentially refers to, see, if you go back to the database story and history itself, right? We started with file stores, then we did structured data, then we had, unstructured data, and then we have, branches of that, like, time series database, graph database.
Yeah.
You have a new kid on the block which is here to stay, which is the vector store. And essentially caches are becoming much more prominent, which is also sort of a database. So traditionally, the way you deal with databases, the kind of data store that you have is changing a bit in Gen AI. So when you are dealing with vectors, you're saving a large number of them, so that cost is different compared to your traditional database cost. So let's say if you're dealing with customer data a lot, having some kind of a parallel customer database in form of vectors to be able to service all of your queries.
Oh, got it. Got it. You mean to see the duplication because of this vectorization and all the stuff
Yes,
that
not just duplication. Duplication is one fact to it. See, traditionally you don't store the relationship between your data, right? So if
yeah, got it. Got it.
so
I'm getting it.
think of it like your each customers had a lot of documents and you want to vectorize and each document and save it. So that's incremental cost. So yeah, that's what I was referring to.
Okay. So you basically in the previous last slide when they're talking about costs, you were saying that the token costs are eventually going to come down, but yes, there are other costs you have to keep in mind, right? Like observability database. Okay. So when you say observability, the regular LLM normal models also have a standard observability, right? You're monitoring and all the stuff, right? So is there from LLM specific any specific
Yes.
observability you have in mind, like?
Yeah, I'm not sure if you scan through the entire talk. Maybe I'll share the slides as well. And once this goes out on YouTube, you can watch the recording. But uh, traditionally, ML ops has been a very well-defined area for past 4 5 years. LLM ops is a newer kid on the area, and it's trying to solve for the ops challenges which ML ops doesn't. So if you think about observability, Gen AI observability is much more larger. So if you have, let's say, Datadog in your system, and if you start logging every chat and every communication, the amount of inflow you would have would be humongous, would be significantly high. That's point one. B, the nature of observability is very different. You want to usually observability is afterthought when you are building a system like logs banalia and you're solving for errors and all that. But with Gen AI, you have to actually get onto forefront and be proactive. Let's say your user asked a question that give me the CEO's salary. You need to prevent that, right? So that can only happen if you have the right evaluations built into it, which can only happen if you have observability built into it. So a lot of different dimensions to observability are around LLMs, focused around kind of data people have access to, focused around the kind of cost attribution you do, focused around how do you decompose data, stores them as vectors and all of that. So different ops conversations from price perspective, performance perspective, and things like that. So yeah, that's what I was trying to communicate.
Yeah, yeah, thanks, God.
All right. Any more questions? If not, I
Uh,
can.
And do you see that? I don't know from your experience. Have you someone tried like orchestrating the same ROM to multiple LLMs and then
Does
getting the best one out in the result?
See, I think everybody who has ventured in this has tried. Prompts are not interoperable. So, if you have prompt in a certain format in a certain order, it will work great for OpenAI. It will not work the same way for Mistral. Prompts have to be tailored and tweaked per model. At least that's the story that's going right now. If this changes in few months or even few weeks, God knows. But prompts are not interchangeable. Is something which at least I have experienced very strongly.
I agree with you. Yeah, but yeah, generic prompts, most of the stuff. They are
Even
okay, but yeah, in enterprise grade, I agree with, yeah, every model should be customized.
even specific. So there's a company I was in a meetup yesterday, and we were talking about AI gateway. They actually have a product which essentially does this. So you can tailor based on the kind of input received. You can tailor the similarity to a certain prompt and then redirect to a certain model. So that flow is very very important, because the conversation becomes very case sensitive, and as you get into specificity of the prompt, like formatting the output, the way the model deals with chain of thought or multi shots, they are different. At least so far they are different.
Okay, got it.
Cool.
So you are saying they had some open source tool which automatically fine tunes or customize the prompt based onto the model it is.
Fine tuning is a very different
No, no,
conversation.
no, I'm not saying.
Oh, okay. Yeah, I get you. Not literally meaning.
They
But
customize your fine tune your prompt
so it's
based on the model. They have some open source tool or something. What is it like?
I'm missing the name. I was talking to them yesterday.
It's okay, fine. Yeah.
Yeah, but there are tools that are solving this problem. So it's not automated, but it's configurable. So you can set thresholds after which the prompts will switch, and thresholds after which models will switch. So if your similarities are not there, because see, automating is very difficult because nothing
I
is
know.
deterministic.
Yeah.
Cool. Great,
Thanks.
great question. I think so. Mist is saying, but I think that's the right behavior and expectation from prompts. Uh, I don't know. I cannot comment on what's right or not. What I've experienced and learned is prompts are not interoperable. That's a ground premise I operate with. If this premise changes tomorrow, I'll be very, very happy. I mean, it's a nightmare to work with different endpoints and different model providers and then understand prompts differently. I think it has to do with the kind of data that each of these players have taken in, and because they have taken different data, different order, different processing techniques, the prompts respond differently. Model architectures are by far and large same. Again, I am zero expertise in that, but my general academic understanding tells me that.
Same model itself, you ask the same prompt.
Well,
That's
that's a, that's a very different problem that can actually be solved by prompting. You can,
yeah, setting the
yeah, expectation.
hyperparameters. Yeah,
Correct,
yeah.
correct. You can make it like a horse with the closed eyes, but every other model has like a different horse with bigger eyes, some with smaller eyes, and whatnot.
Got it.
Akash, have you encountered a multi-model requirement where you have to hit many LLMs? I mean, I have not encountered.
Yeah,
Have you?
I have multiples. I mean, I don't think I've touched my background right now, so I'm moving into healthcare space, and we are venturing and parallelizing and working with a lot of multiple models. A lot outside of my personal experience, I have a lot of friends in professional network who have built chatbots, end user conversation. Like there's a blogging website called Hashnode. I'm not sure if you guys are aware of it. It's very popular. Hashnotes is for developer documentation. They have a chatbot called Rix. Rix essentially is powered by multiple models, and why you would need to know use it is very very clear, because some questions you want to answer fast, some will require deeper reasoning. So think of it like, if it's just a question based on documentation search, like tell me the function for a certain operation, I will not use the biggest model. But if it's a question, right, generate a code depending on this parameter, use this function from JavaScript, use this from Python, I'll use a bigger model. So yeah, I have seen some bunch of them. I know a lot of people who orchestrate across them. And I intend to do the same very soon.
Okay, great. Any other questions, folks?
Okay. Thanks. Formal closing thanks before I pass on to you, Vivek. Please do check out my intro, or like you can hit me at Binto dot the link that I shared. Vivek, is it okay to give my personal reference in the
Yes, yes.
chat, please? Okay. I'll put that. You can hit me up on LinkedIn, subscribe to my channels. That will be amazing. I'm very, very passionate and share everything I know on tech on YouTube. Teach a lot, like teaching. So please do connect on LinkedIn. Please feel free to reach out personally if you have, thoughts, ideas you want to bounce off. I love to get into a deep design conversation. I'm still an architect. So yeah, thank you for listening. Over to you, Vivek.
All right. So thank you, Akarsh. A very interesting presentation. Thank you, folks, for joining. And a different perspective to our webinar series here by Akarsh, more from an architectural and operational effectiveness ideas. I learned a couple of things here myself. Thank you all for joining. Thanks, Akash. Look forward to future sessions as well.
Thank you. Cheers, everyone. Have a good Sunday. Bye bye.